Hello everyone, today I'm going to share you how to determine the threshold for extreme value analysis with the pico threshold method. So as far as I know, like just for me, extreme value analysis is very useful for my PhD and during my 5 years working in the industry. The second would be like how to determine the CDF of GPD with the different confidence interval. Like if you want to do the uncertainty analysis, this is very useful. So I'm going to give you a real example with the real data and the real code, so you can just work on your data yourself. So this data here is for some locations. So we have data from 1981. So this is daily data from 1981 to like 2018. So 37 years of data. And so let's take the example of the rainfall here. So in millimeters, say some days they don't have any rainfall, 0. Some days they have rain like 5 millimeters per day. The code is here, so you just can copy and paste my code here. Let's see, like just first is to read in the data. Just this is my way of execute the MATLAB. So you can see the data I'm reading here as a rainfall here for like more than 13,000 data here. And the second thing would be, the second thing would be like rank the data, like sorted data, and the range 3 is data that will be used in analysis. So this is based on the knowledge that, like say, for each year, like for the extreme value analysis, you need to have the very like basic fundamentals of the analysis. So you have like no more than 3 or 4 or 5 data per year, because you are estimating the tail part of the distribution. So like that's about like 150, like you can just go about 150 to 200, but in my experience, like this data I have already determined, so it's like 150 is enough. But you may want to go further, like maybe to 200, like that's about 5 to 6 data per year. That would be a safe option. But I have already done this, so I know that 150 is enough. So and then we have do the data. So like this is like the top 150 rainfall during the 37 years. And this the thing is you want to do the QQ plot. The QQ plot is the way that you determine which threshold is the best. I just can Google it. Like there are a lot of tutorials about the QQ plot here. So here's the real code that works for QQ plot here. You just copy and paste. The one thing is that you need the statistical and machine learning toolbox for this analysis. So you need to get it. I don't know how to work around this. So you need to use the JP-feed, the empirical CDF, and the QQ plot here. And then you want to execute this code here. And this will give you like this animation of the QQ plot. The QQ plot look like this. So you want your x-axis and the y-axis to be like the 1 by 1. So just like you want your arrow to be small and you want the slope to be 1. Here is like this only 5 data. So this go from 150 data from 2 data to all the way to 145 data. Here, oh no, this is not. This is like should be a loop. Let me see, like 1, yeah. Yeah, this should be like from like 149 data to all the way to 5 data here. And then you just calculate a lot of QQ plots. So the first thing, like this is done by me. So if you want to use my code, just it's best if you can just get my credit here. So and then you want to do the plot the arrow and the slope of this QQ plot here. So here is the QQ plot slope for different data. So this can say like each data corresponding to like each data in our data set correspond to the value here. So you want your slope to be 1, and you want your arrow to be 0. So based on look at data, like there are a lot of things slopes as is 1. You want to look at the smallest slope, smallest arrow here, excuse me. So this will give you smallest arrow is 37.7. This will give you the best threshold to use in your analysis. And we know that this is the 37.7 is the threshold here, and then we want to do the analysis. Like here at the code, just copy and paste, like just do your own code similar to this one. And here we have the confidence interval here. This is 95%. You can just change this. I think the GP feed can give you a different confidence interval, but I'm using the 5%, 95% here. Like in a lot of uncertainty analysis, you need this one. And here are the code. You can just execute this code here, and this will give you like, okay, 5%, 50%, and 95% of confidence interval here. It all start from like this is 30, your threshold like 37.7 around there, and all the way to a different value. So like this 90% cumulative function will give you very different results, like of the different confidence intervals here. Yeah, that's it. So, and looking at this threshold here also, and all the data are here. So this is the 95% confidence interval, and here is the 50%. So usually you just use the 50%, but you never know when you need the uncertainty analysis. And here I write down all the things here, and then you can just do your, like, just calculate the, like, say 100-year rainfall, like 50-year rainfall based on the data here, and it should be very straightforward. Then I write the data to a file here. So this is the way to pick up this threshold for the JPD distributions. And there's another way I'm going to tell you in the next video, is using the software package called WAFO, W-A-F-O. I found that one is also very useful. I'm going to tell you in the next video. Thank you for watching.